Okay, for question number 30, it's given that an object of height 5 centimeter is placed at a distance of 20 centimeter from the optical center of a convex lens of focal length. So this is the object height, which is denoted by h. So this is question number 30 part. This is first part, and we have the sub part 1 of part 1. So height of the object, it's given as height is 5 centimeter. Now is played at a distance of 20 centimeter. So object distance u is, sorry, this is minus 20 centimeter. And focal length is a concave lens. So focal length for concave lens as per sign conventions is negative, which is negative 18 centimeter. Now we have to find the image distance and the magnification. Now the image distance is, and the magnification is m. So using lens formula, which is 1 upon v, use negative 18, f is, sorry, use negative 20. Okay. So now the LCM of 18 and 20 is 360, which gives me it's negative 20 minus 18, which is equal to negative 28 by 360. That means V is equal to negative 360 by 28, and this is now 14, 187, and 90, which is equal to minus 90 by 7. So V is equal to, this is now okay, this should be actually 38. This is negative 38 by 360. So V is equal to negative 360 by 38. This is 19. This is 180. So negative 180 by 19. And so this is equal to negative 9.47 centimeter. So the image is formed on the same side, that is in front of the lens and at a distance of 9.47 centimeter from the optical center of the concave lens. So we can see that it is formed, or the image is formed at a distance of 9.47 centimeter from the lens. Okay, now we have to calculate the magnification, and now magnification for the lens is given by the formula V by U, and V here is, this is negative 360 by 38 divided by U, which is negative 18. So this is 360 by 38 into 1 by 18. This is 20. 10 and 19. So magnification here is 10 divided by 19, and that should give me the value 0.5. So V is 360 by 38 divided by 18. U is 18. And this is, so this is zero point 0.5. Magnification is 0.52. That means that the image is smaller, image size is smaller than the object size. Okay, for next one, moving on to the next part, we have to compare the values of magnification obtained by concave lens and a concave lens when both lenses form virtual images. So let's take the concave case of concave lens first. So this is part second, and for concave lens, the image formed is virtual. So in both the cases, for concave and the convex lens, we have to uh, compare the values for virtual images. So for convex concave lens, let me show you how the virtual image is formed. This is the virtual image, and now let this be a concave lens. ऐसे ही मत बैठे रहना, सुनना है मैंने। ठीक है, इस बात का ध्यान रखना कि मेरे सामने बैठे हो। हाँ, करो इसको। हम्म Okay, so here we have for concave lens, we have to form the virtual image. So in concave lens, we have only two cases where the object is either at infinity, light rays are either coming for infinity, or the object is placed between the twice of the focal length, that is between two center of curvature and the principal focus. So that's the only case where the virtual image is formed for concave lens. So between, or we can say between the infinity and the optical center of the lens. So that's the case when the virtual image is formed. So so let's say this is the optical center. This is the first principal focus, second principal focus, and let object be placed here. So object is upright. The ray that's going parallel to the principal axis is diverged and seems to be coming from the focus. So it seems to be coming from here. So that means we have to draw this as the dotted line. Okay, so this is how the ray is diverged. Okay, now let's take another ray of light that is going through the optical center, and both these are intersecting at this point. So this is the point where the virtual image is formed, and let this be a dash b dash. Okay, now in this case, you see the size of the object is greater than the size of the image. So this is a virtual image formed in case of a convex concave lens. So that means we know that the magnification is also given by size of the image divided by size of the object. Now this is smaller than h dash. Size of the image is smaller than h. Okay, let's say it's 2 by 3. So obviously the answer would be less than 1. So here the magnification will be less than 1. Okay, now let's check the case for the convex lens. Okay, so let's say this is a convex lens. This is the principal axis. And first principal focus, second principal focus. Now we have to form, in this case, the virtual image. So that means the object is placed between the optical center and the principal focus. So the ray of light that goes parallel to the principal axis passes to the focus. So it goes like this. And we will produce it in the backward direction because, and this is a dotted line because we are assuming this light is going here. Okay, now let's assume another ray of light is going through the optical center and it will just go like this. So these are the rays of light, but we will assume this to be coming, this to be and we have assumed that these rays of light, when produced in the backward direction, they assume they intersect at this point. So this is where a virtual and magnified image is formed. This is A dash B dash. Now, in this case, this is the height of the image, this is the height of the object. And magnification for the lens is given by h dash by h. Here, h dash is greater than h height of the image or the size of the image. Let's say it's 5 and it's smaller, let's say it's 2. So obviously this will be greater than 1. So this value will be greater than 1. That means the magnification is greater than 1. So for this, our answer should be in terms of magnification. If we have to write in terms of magnification, then we will write that uh, for convex lens, magnification is greater than 1. So you need not have to draw these diagrams. I just draw it to explain you how the magnification is greater than 1. For magnification, in case of a virtual image is formed, magnification is greater than 1. And for concave lens, or magnification is less than 1. So this is what you have to write as an answer. Okay, let's move on to the next part, and that is the or part. It says a convex lens forms a real, inverted and magnified image as well as virtual, erect and magnified image. So for the virtual, magnified and image, so for virtual, magnified and erect image, we have the ray diagram. Let's draw it for the real, inverted and magnified image in case of a convex lens. And if the focal length is 10 centimeters, so this is, let's say, the first case, this one. Or going to raise this. So we are doing the or part. Okay, for our this is the virtual, erect and magnified image. So this is the second part. So this is the virtual, erect and magnified image. In this is our part. Okay, now we have to form. Let me take all this off. So now we have to form a real inverted and magnified image. So let's see what is the case for real inverted and so real inverted and magnified image in case of a convex lens is formed when object is uh, distance greater than the focal length. So we have to form a real magnified and inverted image. So the real magnified and inverted image will be formed when object is placed between the focal length between f1 and 2f1. So that's the case between f1 and 2f1, or we can say that when the object is placed between the focal length and twice the focal length. So let's draw that ray diagram. So it's between f and 2f1. Or we can also take the image. So it's between f and 2f1. So object should be between f and 2f1. So let this be the object between f and 2f1. So this is the case when we have the real inverted and magnified image. Okay, now this goes through the optical center, intersects here. This is where the image is formed, which is real magnified and inverted. This is A dash, V dash, arrow is pointing downwards, it's inverted. These are the directions of the rays. So, okay. And this image is formed beyond 2f. So this is 2f2. Okay. This is the object AB, and this is the image A dash B dash. Okay, so these are the two cases, and where the image is formed. So in this case, the image is real, inverted, and magnified, and in this case, the image is virtual, erect, and magnified. Now, let's read out the question. If the focal length of the lens is 10 centimeters, so the focal length is 10 centimeters. This is the focal length between the optical center and the principal focus. So this distance is 10 centimeter. This distance is 10 centimeter. Okay. What should be the range of the object distance in both cases? So in both cases, the object is placed here between optical center and principal focus, that is within a 10 centimeter from the convex lens here. And so this is 10 centimeters, so that means this distance is double, which is 2f, which is 20 centimeter. So that means the object should be placed to get, so object should be placed between 10 centimeter and 20 centimeter. So that's the range for the object. So between 10 and 20 centimeters. So that means the object distance should be uh, greater than 10 centimeter. So between 10, or we can say that it's between 10 and 20 centimeter. That is U object distance is greater than 10 centimeter but less than 20. So this is 10 centimeter and less than 20 centimeter. That is the range of the object distance. So this is the range of object distance in both the cases, and we have drawn the diagrams to justify the answer. So in the first case, it's between 0 and 10, and the second case, the in this case, object is between 0 and 10, and in this case, the object So this is 0 and 10, and in this case, the object is between 0 and 20. So between 10 and 20 is the answer. This is the range of object distance, which is denoted by U. And these are the ray diagrams, this one and this one. Okay, let's move on to the next one. That is next question. That is question number 31.